Hi everyone, this is Desiree Delisay, and for today I'll be sharing with you how to use social science statistics, specifically the statistical test of chi-square test of independence. Okay, so there are two types of chi-square. So we have goodness of fit and test of independence. So for goodness of fit, we wanted to know whether actually the main concept of chi-square is to know whether the expected value is different from the observed value rather is different from the expected value. Okay, so chi-square is a non-parametric test. It doesn't assume normality of data, and it's very good for small sample sizes. Okay, so now actually we have here different um, calculators for chi-square. So this is for goodness of fit. You assume that all categories have the same expected value, and we have contingency table. So let's just have the contingency table is for test of independence, whether the values are independent from the expected value. Okay, or if you can associate actually the variables from another categorical variable. So we have here, for example, the one that I used is whether sex is associated with the decision in changing um, their views about the revision of a student body. So let me just have this one first so that I can explain it to you. So we have here categories and group. Okay, so let's take for example that our category is whether they agree or disagree. So the situation is there is a survey wherein the student body wanted to know if the students are in favor of revising the constitution or their student body constitution. So that's just agree and disagree. And we wanted to group them according to sex, which is male and female. So as I'm always telling my students and I'm always sharing with you, if gender is very important to your study, use the classifications of gender, and you should report what genders or what gender types are you going to use. But if it is not really that important in your research and for demographic purposes only, then you can just use sex, which is male or female. Then let's click next. Let's say for the male, actually I already have the data with you. So for the male, 30 agree and actually 25 disagree. We have for female, 40 agree and we have 15 who disagree. Okay, so let's just use this data. And of course, you can, if you have a survey, you need to create first your contingency table so that it will not be hard for you to enter the data, and you tally them. Okay, and make sure all the boxes here or all your what do you call this, all your cells have at least three respondents so that it will not make your table bias or it will be invalidated. Okay, so you just click next. And for that, okay, so we have, let me just explain this to you. We have marginal row total, so that's 30 plus 20, 55, 40 plus 15, 55. So we have marginal column total, so we have 70 and 40, and grand total or the total sample size that we have is 110. So why do we need the marginal totals? If you are going to compute it manually, you need to compute for the expected value by multiplying the row total and the marginal column total divided by the grand total. So for example, for 30, these are the expected value. 30, 25, 40, let me just correct it. So 30, 25, 14, 15 are your observed value. It's the reality. Okay, it is what you have computed with your data. Now we are going to get the expected value by multiplying the marginal row total to the marginal column total divided by the grand total, because we wanted to have the proportion or the expected value that we have with respect to the totals presented here. So for example, if you wanted to have the expected value for 30, that is just 70, which is the column total. Then you are going to multiply it by 55. So that is 70 times 55. It will give you 3,850. Then you divide it by the grand total, which is 110. So that is 35. So the expected value for the male students who agree is 35. Okay, then you can just check it. Then you just click, yeah, chi-square. Now, if you can see, the one in the parenthesis is the expected value. So, have here, the chi-square statistic is 3.9286. The p-value is 0. Ooh, so significant at p less than 0.05. So we have the correction. If you're having, we call this advanced research already, so you can have the corrections. Not familiar with this correction, but there are some statistical tests that actually adjust certain degrees depending on the data given. Okay, so you can just focus on this one. Okay, yeah. Okay, so it's significant. Therefore, if we are having the research question as is sex associated with their responses, therefore the answer is sex is associated. Kasi we are going to reject the null hypothesis and accept the alternate. The null hypothesis is sex is not related, while we actually rejected it. So that's sex is associated with their response, whether they agree or disagree. Now, there is this tab here. We can check this out. So, how to report a chi-square result. So, here you can just look for this one. But this is very important, this one. So, chi-square, you have degrees of freedom. By the way, to get the degrees of freedom, you just have column minus 1, the number of column minus 1 times row minus 1. So the number of columns that we have a while ago is 2. You have there agree and disagree. And for rows, we have male, female. So that's also 2. So minus 1, minus 1. You have 1 times 1 is 1. And you have n as the sample size. Then you have x. N is equal to, we have 110 a while ago. And we have 8.9. This is your computed chi-square value. And the p-value. Okay. And you interpret it. So you can get this as your template, so that, but don't forget to change the values and change the interpretation, of course. And by the way, chi-square, I think chi-square um is not in Excel, so that's why excuse me, using this calculator is very useful for you. Okay, so I think that will be all for this chi-square tutorial, and I hope that you learned something. If you have questions, and just comment down below and I'll try to answer as quickly as possible. So that's it for chi-square, and I'll just see you on the next video. Bye.